Hey guys, we are talking about shifting, reflecting, and stretching graphs today. Make sure my pen's working. Okay. And so let's talk about what's a vertical shift. So remember that anything that changes a graph is just called a transformation. So a vertical shift is a transformation of the function where a new function, h of x, is the old function f of x plus or minus some value of c, where it moves f of x up or down c units. So if it's f of x plus 2, that means we're going to take the function of f of x and just simply shift everything up 2. A horizontal shift is really similar. It's where a new function equals the old function of x, but inside the parentheses of x, we add or subtract a value of c. And so what this does, it shifts a value of c in either left or right. Keep in mind, if c is if it's a minus c, it goes to the right. If it's a plus c, it goes to the left. Okay. Rigid transformations, and this just means that the basic shape is unchanged. It's just moved up and down, right or left, or maybe flipped over. So the basic shape is unchanged. And then a non-rigid transformation means that there's a change in the original shape. It could be stretched, it could be compressed, but somehow it looks different. Okay, so let's talk about parent functions. A linear function we've been using a lot, for example, could look like this, where this is like f of x equals x. That's a type of linear function. It's not the only one, but it's one that we use a lot. An absolute value function looks like this, right, where absolute value of x and absolute value functions look like a v. A square root function looks like this, where typically any square root function can be anything with a square root, but this is the most common one. And a quadratic function looks like this, where f of x equals x squared. Remember, anything with an x squared term is a quadratic, so no matter what it has in there, if x squared is the biggest term, it's a quadratic. A cubic function looks like this, where it's f of x equals something x to the third. And then lastly, a rational function looks like this. And that's because it has a root, or, not a root. That's a radical function. A rational function means it has like a fraction, like f of x equals 1 over x. So it could look like this. And then that can also be negative like this. The only thing it can't be is, remember that x cannot equal 0 on this one. So let's talk about vertical and horizontal shifts a little bit more. Vertical shifts upward it'll be like h of x equals f of x plus c. So if it's plus c, it's up. If it's downward, it will look like f of x minus c. If it's a shift to the right, it will look like f of x minus c inside the parentheses. And if it's to the left, then it'll be an f of x plus c also inside the parentheses. So remember, in the parentheses tells me it's horizontal. If you had me last year, we call that funky town, right, where minus c looks like it should be to the left, but it's really to the right. Plus c feels like it should be to the right, but it's really to the left. And then outside of the parentheses is just pretty normal. And then so if we're looking at if the function is the absolute value of x, let's write it so that it will shift vertically 3 down and horizontally 2 to the right. So remember, shifting down, so we're going to write a new function, g of x. So that means the absolute value of x has to be part of it, right? So shifting down means we're going to go outside the parentheses or absolute value, we're going to go minus 3. That tells me it's going to go down 3. And then the other part is shifting 2 to the right means that I'm going to go, just like here, to the right, means we're going to go a minus 2. This goes right, 2. And again, the 3 was down 3. Let's talk about what a reflection is. So reflecting a graph, so let's say, for example, you have a parabola that looks like that. If I were to reflect it over the x-axis, it would be the mirror image over this line. So a reflection in the x-axis is a type of transformation, and it's represented by the negative times the function of f of x. So if this is f of x, this is negative f of x. And the y-axis, if I've got, I don't know, something that looks like, maybe like this, okay, if that's f of x, then h of x is going to be f of negative x. So if it's flipped over the y-axis, it looks like this, and if this is f of x, this is f of negative x, okay? So for example, again, f of x equals the absolute value of x. Describe what happens if I multiply the whole thing by a negative. So remember, it looks like this up here. So that's a reflection over the x-axis. So let's draw this. So if the absolute value of x looks like this, if I'm flipping it over the x-axis, that's right here. So we're kind of flipping it over. So this is going to literally flip upside down, and my new drawing is going to look like this. So it's going to look like it got flipped upside down. Okay. And then non-rigid transformations, remember there's 3 types. If it's horizontal, it can be a horizontal shift, right, left or right, vertical shift, up or down, or it could be a reflection over the x or the y-axis. Rigid transformations only change the position. They don't change anything else, right? It doesn't change the actual shape. For non-rigid, so they could be either a vertical stretch, so we're stretching it in a vertical direction, or it could be a vertical shrink. We also call a vertical shrink a compression. Or it can be a horizontal stretch, so stretching it horizontally, or a horizontal shrink, which we also call a compression. And non-rigid transformations multiply by a value of c. So it's a vertical stretch if c is positive and bigger than 1, okay? Or it's a vertical shrink if c is a fraction but still positive. A non-rigid transformation, when we multiply the x inside the parentheses, is a horizontal shrink. Or if it's a fraction inside the parentheses, we call that a horizontal stretch. Again, if it's inside the parentheses, we call that funky town. It just kind of does something that it's kind of counterintuitive. All right, I'll see you back in class.